Welcome back to Chapter 8. We are out of order for this section, and I have it notated. I have it arranged that way in my math lab. I have it notated in Canvas, and I've got noted here on our guided notes. After 8.2, we're jumping all the way to that last section, 8.5, and doing it before we go back to 8.3. In section 8.5, we learn how to use the polar coordinate system to graph points. And this is just kind of fun and easy, and I thought it was a really good next thing to do after we figured out how to use that RCIS theta, that polar form of complex numbers. Okay, so as an introduction to our polar coordinate system, you'll notice that it looks like we've got bullseyes drawn here. That's our polar coordinate system. But if you look, we have some of our special angles drawn in. We've got 30, 60, 90 because these angles are equally dividing our quadrant into 3 pieces. So from 0 to 90 degrees, we've got 30, 60, 90. So we're missing our 45-degree special angle here on this particular polar coordinate graph. When you have a polar graph that you're given, make sure you stop and take a minute to see which angles are represented and which angles are added in or maybe missing. Alright, on our polar graphing system, it's based on a point called the pole. Now this pole is what we would call the origin on our rectangular coordinate system, and a ray, which is called our polar axis. And that polar axis is drawn in the direction of the positive x-axis. So when we look at our polar coordinate system, we've got the pole here, and this is our polar axis, and we are thinking about rotating this polar axis around the pole. If we are moving in a positive direction, we're going counterclockwise, just like we're used to. We're moving clockwise, that means our angle is rotating in a negative direction. Rectangular and polar coordinates. Now we already know this. This is a review as to how these values relate to each other. Our rectangular coordinate system has the coordinates x, y to represent a point, and the polar coordinates that represent that point will be r theta. Here is how they're related. X is r cosine theta, y is r sine theta, because we know that cosine theta is x over r, and that's when we solve for x. Sine theta is y over r, and we solve for y. We've been given this r squared equals x squared plus y squared. It's our Pythagorean theorem, rewritten in terms of graphing. But remember that we think of r as our modulus. And then we've got tangent theta as y over x. This helps us find theta if we need to. So none of this is new, except this introduction of our polar coordinates as r theta. Now, when we are graphing a set of polar coordinates r theta, I want you to remember that you want to find theta first. Then move to r. Whoops. My mind was working faster than I was thinking through that. Move to whatever value r is given as. Now, when we're graphing our point xy, typically we find that x coordinate, we move horizontally left or right, and then we move to the y coordinate up or down. When we're graphing our theta, our polar coordinate, we want to find theta first. Now it feels a little awkward, but I promise you it's going to be more successful. Okay, let's plot some points. First we're going to plot the point, and then we're going to turn our value r theta, our polar coordinate, into rectangular coordinates. So let's plot this point first. We've got 135 degrees. Well, if you think about your unit circle, and I've got mine here somewhere, let me grab it. If you think about your unit circle, 135 is that 45-degree reference angle in quadrant 2. And I just let you know that we don't have a 45-degree angle drawn in here. So I'm going to need to go in, and 45 is halfway between the quadrantals. So I'm going to go in and split that middle section so that I have 135 represented here. So to get to point P at 135 degrees, I'm rotating my polar axis to 135 degrees. This is the angle I'm after. And then point P is at 4 as my value for R. So I go out 1, 2, 3, 4 units from the pole. And there is P for 135 degrees. Nice and simple, right? Okay, next step, we need to turn it into rectangular coordinate form. So we want to move r theta into xy coordinates. And I'm going to use my knowledge here that x is r cosine theta and y is r sine theta. So I need x and y. I'm going to do x as r cosine theta, y as r sine theta. R is 4. I need the cosine of 135 degrees and the sine of 135 degrees. And we know these values. This special angle on our unit circle is my 45-degree reference angle, so it's square root 2 over 2 in quadrant 2, so my x is negative. Now I'm pointing here, I'm thinking about picturing my rectangular coordinate system overlaid over my polar coordinate system. So I've got 4 times a negative square root 2 over 2 for x. And I've got 4 times a positive square root 2 over 2 for y. So my coordinates in rectangular form are negative 2 square root 2, positive 2 square root 2. And if I were to overlay a rectangular coordinate system where I had vertical and horizontal lines instead of circles, that would be this location on that coordinate system. Okay, let's do B. We're going to plot point Q. 30 degrees is my r theta form. Remember, find theta first. Well, 30 degrees, that's this special angle. So I'm going to take my polar axis and I'm going to rotate it 30 degrees. That's right here. I need to move positive 2 units. So that is the location of point Q. That's 30 degrees. So I know when I get my coordinates for xy, my rectangular coordinates, it's going to be positive and positive. This x value is going to be larger than the y value. Let's go over and find xy. So I know that x equals r cosine theta, y equals r sine theta, and for this problem, r is 2, theta is 30 degrees. One of my special angles, so x is going to be 2 times square root 3 over 2, y is going to be 2 times 1/2. So I've got square root 3 and 1 as my x and y values. So my rectangular coordinates here, square root 3, 1. Now I want to point out something. We're going to get it in the notes here in a minute, but for my rectangular coordinate system, this is the only way to get to this location. That's the only ordered pair that gives me that location for my rectangular coordinate system. But what about for my polar coordinate system? Well, I am rotating an angle around the pole. I can just keep rotating, right? I'm going to keep coming right back here. So that value 2 isn't going to change. But if I go one more rotation, I could also call this 390 degrees. If I add 360 to that, I could call it 390. So I could add rotations. Oh, good grief. There we go. Let's just... sometimes best laid plans. Okay, 390 degrees. I could keep going. I could add another rotation and another. I could subtract a rotation. I could rotate clockwise. It could also be called 2. If I go a negative 360, that would be negative 330 degrees. We're going to talk about negative values for r in a minute. That gives me a whole other set of coordinates. So there's only one rectangular coordinate pair, but there are infinite numbers, infinite polar coordinates that fit that one point. Because with polars, I can think of angles of rotations. Just keep that in mind. We're going to see that again in your notes so that you don't forget. Let's do some more. We've got C, D, and E as graphing. Here we go. So two things here. For r, I've switched to a negative value for r, for the modulus r, and then I've got 2 pi thirds, which is radians. But you guys know radians. Radians aren't a problem, right? We might want to pull out our unit circle if you don't have it memorized. See where memorizing the circle will get you helped. 120 degrees is the same as 2 pi thirds. That's that pi third or 60-degree reference angle off of the x-axis. That's the location for 2 pi third. You always find theta first. Sorry, I lost some of my colors. I'm going to find theta first, so I'm going to go to 2 pi third, rotate it around right here. There's 2 pi third, that's my angle. And then I'm going to go to -4. Now, if I were going to +4, I would locate 2 pi third and I would move in a positive direction, 1, 2, 3, 4, and there I would be. But I need to move in a negative direction. So I rotate to 2 pi third, but then I follow it back down the other direction. That's my negative direction. This would be 1, 2, 3, 4, +4 2 pi thirds, which was not what I was asked for. 1, 2, 3, 1, 2, 3, 4. This is -4 2 pi thirds, which is what I was asked for. Point R. You're going to notice this down here in the 4th quadrant instead of the 2nd quadrant. So we found the location for R. That's what I'm after. Now I need to put it in rectangular form. Two pi thirds is a special angle. It's that 60-degree reference angle. So and it's in quadrant 2. So my coordinates are -1/2, a positive square root 3 over 2. I end up with a +2 and -2 square root 3, which would throw me into my 4th quadrant if it was rectangular grid. We've got another one with a negative value. For D and E, this point Q and this point R, I encourage you to pause the video, do them on your own, and then see how you did. There would be a positive pi6. I'm going to move out to a negative pi6. I'm going to move to positive pi6 is my value for theta, and then I move in a negative direction for my value r. So that is point Q at -3 pi6. Pi6 is in quadrant 1, but -3 as my value r moves me back here into quadrant 3. And then I come over and I find my rectangular coordinates. Remember, when we are plugging in for our rectangular coordinates, we're using the values for pi6, which is in quadrant 1. These values I'm plugging in for cosine and sine are positive values, but then I'm multiplying it by a negative value for r. So that when I get my rectangular coordinates, they are both negative, which would put me on my rectangular coordinate plane into quadrant 3. Alright, and then finally, well, we've got one more on the next page. So now we've got a negative angle here. This is new. Hopefully you paused me, you went ahead and did this, and you figured it out. when I do that value theta first, if I rotate to a negative pi halves, that means that I'm taking my polar axis and I'm rotating it clockwise. So if I rotate that clockwise, negative pi half is right here. Move out to 2, a positive 2 down here at negative pi half puts me here for point R. Whoops, that is a positive 2 at a negative pi half. Positive 2 is the coordinate for negative pi half. It's on this quadrantal heading south, right? And then I find my rectangular coordinates. Well, right here for this, the coordinates on the unit circle for this would be 270 degrees or 3 pi halves if I were moving in a positive direction. It's going to be 0, -1. So the rectangular ordered pair that would mark this point is going to be 0, -2. This is the only rectangular coordinate on the rectangular coordinate system that will locate this point on the rectangular coordinate system. But if I'm thinking about polar coordinates, I have an infinite number of polar coordinates. Infinite polar coordinates. Because I can just keep rotating. I can say, okay, well, I'm at negative pi half. I can keep going that direction. That would be another 2, so there'd be 5 pi halves. So I could do 2 -5 pi halves. I could do another 4, so there'd be a 2 -9 pi halves because 4 pi halves is 2 pi. I could rotate back in a positive direction, so I could add 2 pi. So that would be 2 3 pi halves. That's that same point. Or I could think of, if I could make R negative, which I can, I could rotate pi half and then go to a -2. I nearly put it in the wrong order. I can rotate to positive pi half and then move to a -2. Or I could go to -2 at a positive 5 pi half. That would be 4 pi half, one more is 5 pi half, and then backwards to a -2. So all of these are polar coordinates that map me to that point, that location. All right, one more to practice with. See what you can do on your own. And then we'll look at it and see if you got it right. Oh, pi fourth. Remember that's not there, so that would be halfway between 0 and negative pi half. If I move out to positive 5, so I rotate clockwise to get to the negative pi fourth there, out to positive 5, 1, 2, 3, 4, 5. That point S is right here, 5, negative pi fourth. And then I need to do my XY coordinates. Cosine of negative pi fourth. Y is 5 sine of negative pi fourth. Negative pi fourth is the 45, or the pi fourth here in quadrant 4, which means x is positive, y is negative. So I've got 5, and that is going to be a positive square root 2 over 2 for cosine. 5, and that is a negative square root 2 over 2 for sine. So my rectangular coordinate pair looks like this. My XY coordinate pair, my rectangular coordinate pair. We started with R theta. We changed it to XY. Both of these are this location on my graph. And then I promised you that it would be stated for you. Here it is. While a given point in the plane can have only one pair of rectangular coordinates, the same point can have an infinite number of pairs of polar coordinates. Now we've got an opportunity to practice that a few times, a couple of times. I think this is our last page. So we're going to practice this a couple of times. It says to give 3 other pairs of polar coordinates for the point 5, negative 110 degrees, Well, we're going to go a little bit above and beyond. We're going to graph that first. So let's think about this on our polar grid. So I'm just going to put curves here to represent my circles. 1, 2, 3, 4, 5. I need to go to a negative 110 degrees. So my polar axis is going to rotate. This would be negative 90. Another 20 degrees is going to be a negative 110, right? So that's going to be my angle theta, negative 110 degrees. And I need to go out 5 units on that. So if I had my circles, my bullseye drawn, that would be 1, 2, 3, 4, 5. So my point P is at 5, negative 110 degrees. Now I was tasked with finding 3 other pairs of polar coordinates. So I need r theta. Well, let's keep going in a negative direction one more time around. So I'd do a negative 360 with that. That gets me to 5, negative 470. If I added 360, a positive 360, that would put me at 5, and 360 minus 110 would be a positive 250. So if I start at my polar axis and I rotate in a positive direction, that puts me here. If I think about that back side of this, so how far off, this is 180. So to get to 250, that's another 70 degrees, which means this is going to be 70 degrees if I rotate in a counterclockwise direction. And if I move backwards here, that's going to be a negative 570. That's a third possibility. Alright, this one says give 2 pairs of polar coordinates for the point with rectangular coordinates. So this is my rectangular coordinate pair, x, y, and we need to change it to polar coordinates, r theta. Well, let's think about what we got. If I'm going from rectangular to polar, I've got 3 steps. My first step is to sketch. Got my real axis and my imaginary axis. And if I have the point positive 6, negative 6 square root 3, positive 6, negative 6 square root 3, I am, say here, that's going to be the end of that vector. There's my angle. So I'm in quadrant 4. R is the square root of the sum of x squared plus y squared. Now let's give this a little bit of thought because we haven't done this before. 6 squared is 36. That's very straightforward. I know this is going to come out positive. 6 squared is 36 times 3 squared. Well, let's think about this over here. That's the same thing as 6 squared times square root 3 squared. 6 squared is 36. Square root 3 squared is 3. So this is equal to 36 times 3. I've got to square both of those pieces. And 36 times 3 is 108. So that gives me 144, which is a perfect square. R is 12. Now I need to figure out what theta would be. That's my second step. First, sketch. Second, find R. Third, use tangent. Theta is y over x to find theta. So I've got negative 6 square root 3 over 6, which gives me tangent theta as a negative square root 3, and I know I'm in quadrant 4. Well, which angle has a tangent function value that is a negative square root 3? Just keep it in degrees. Theta there is going to be 300 degrees, so my angle theta. Well, we now know R and we know theta, so my polar coordinates, I've got 12, 300 degrees. That's 1. Right there, 12, 300 degrees. What would be another? Well, I could add 360 to that, so I could say 12, 660. I could go backwards this way, which would be 90 plus 60 is, no, 90 plus 30, right? Because 300, 90 plus 60. Yeah, 150. That gets me at 150. And I misstep there. 60 degrees here is going to be 60. Oh, no. I was right the first time. Forgive me, guys. This is 60 degrees off of the x-axis, which means this is 60 degrees off of the x-axis, which does put me at 120 there. So if I think about that as being 120, and then I need to go backwards, that would be negative 12 off of 120 degrees. And I was just asked for 2 pairs of polar coordinates. There's 3 pair of polar coordinates.